Right. A man is applying a force on a pulley and keep 10 kilogram mass in equilibrium, as shown in the figure. The pulley is smooth and the string is inextensible. Find the force applied by the man on the string to keep the mass in equilibrium. Right. So let's get into the question. So here, let's assume this man applies a force F here. So one thing we need to remember, the force applied here is equal to the tension here, T1, let's say, because it's the same wire of the pulley. Right. Here, this tension is different. Let's take it as T2. Right. Because of these two, this 10 kilogram is in equilibrium. Right. So let's draw it properly now. So here you can see T1 and T2 forces holds this 10 kilogram mass. So let's apply the values for the equilibrium. Upwards forces is equal to downward forces. So upward forces by tension. Here this angle, here it is 60 here, so it's 90, so it's 30 here this angle, and here it's 60. So we have to take the components T1 cos 30 upwards plus T2 cos 60, that is equal to 100 Newton. Right. So let's simplify it furthermore. Cos 60 3 over 2 T2 cos 60 half, so that is equal to 100 Newton. Again simplifying a bit more, so here we get T1. Yeah, this is the equilibrium now Vi. So to make it furthermore, so we need to find connection between T1 and T2. So let's find the connection between T1 and T2 in this direction. Right. So for this equilibrium in horizontal direction, we get T1, yes, T1 sine 30 equals to T2 sine 60. Right. So T1 sine 30, that is half, equals to T2 root 3 over 2. So here you can see T1 equals root 3 into 2 into T2. Right. Then again T2 equals T1 over root 3. Right. So let's apply it here. So now we need to find T1 because it is equal to the force applied here F. Right. So our plan is to find T1. Right. Then apply in the values. So T1 into root 3 over 2 plus. So for this T2 we can apply from T1. So T1 over root 3 into half equals 100 Newton. Right. So T1 into root 3 over 2 plus T1 root 3 over 2. So let's add these two. Let's take the common denominator as root 3 into 2. So here we get T1 root 3 into root 3, we get 3 here plus root 3 over 2, that's T1. So here we get 4T1 root 3 into 2. Right. So let's equal it to this 100 Newton. So 100 Newton. So T1 equals 200 cross multiply into root 3 divided by 4. So here we get 50 root 3 as our answer. That's T1, and this T1 is equal to force applied here. So we can conclude we have the answer